Imagine this. You open BGMI on your phone, you tap Start Match, and 30 seconds later, you're standing in a plane with 99 real people from all over the world. In this video, I want to walk you through how that actually works. Let's start with the bird's eye view. When you tap play, your phone isn't talking to just one server. It's talking to a whole fleet of services, each with its own job. 6 core services. Login knows who you are. Matchmaker finds you 99 strangers. Game server runs the actual island. Voice handles squad chat. Anti-cheat watches for impossible plays. Storage remembers everything after the match ends. Before any of those even hear from you, your phone hits a gateway. The gateway is the front door. It routes your traffic to login first, then matchmaking. The gateway translates your phone's standard TCP traffic into the binary protocol the game server fleet speaks. It also handles auth tokens and connection pooling. Your single device might end up talking to 50 different backend instances over one match. Now let's walk the full journey. Tap to match, 3 steps, 30 seconds. Watch what happens behind the scenes. Step 1. Your phone hits the gateway, which forwards to auth. Auth verifies your account, pulls your inventory, your rank. You exist in the system again. Step 2. You're handed off to the matchmaker. Matchmaker drops you in a queue keyed on your region, your skill rating, your selected mode. You wait there with everyone else looking for a similar match. Step 3. The matchmaker has its 100 players. It books a game server, usually a fresh container in the closest data center, and tells everyone the connection details. Now your phone connects directly to that server. All 3 handoffs in 30 seconds. Auth, queue, game server. The matchmaker is the conductor. Your phone doesn't pick the game server, the matchmaker does. Matchmaking. The problem sounds simple. Find 99 other people. Solving it well is harder than the rest of the system put together. Your phone never talks to the game server directly during this phase. Everything goes through the matchmaker. That layer is what lets the system retry, reroute, or rebalance if a game server falls over mid-match creation. Players don't compete with everyone. They compete with their bucket. Bronze, silver, gold, platinum. The matchmaker holds separate queues per bucket, so a brand new player isn't dropped against pros. When a bucket has 100 players whose ratings are within a window, a pair worker scoops them, books a server, and notifies everyone. The window widens if you've been waiting too long. Behind every match decision is the skill DB. Every player's rating, indexed by region, fast read from a key value store. Every match end writes new ratings back. It's the most touched data store in the whole system. The game server. This is where the actual island lives. One computer simulating every player, 60 times a second. 100 phones, 1 server. The server is the source of truth. If your phone says you fired a shot, but the server disagrees, the server wins every time. The server runs in discrete ticks. Tick 0, tick 1, tick 2. Each tick, it reads everyone's inputs, runs physics, resolves collisions, then broadcasts the new state. 60 ticks per second. Phones send inputs, buttons pressed, joystick deltas, fire commands. The server runs physics and decides what really happened. Your phone is essentially a controller and a screen. The server doesn't send the full world every tick. It sends deltas, only what changed. A player moved, a crate broke, a vehicle exploded. That's how a 100-player match fits in cellular bandwidth. Networking. Keeping a phone and a server in sync over a flaky cellular connection turns out to be the hardest part of the whole system. Every input you make travels phone, then gateway, then game server. Target round trip, 30 milliseconds. Above 80 milliseconds, you start feeling lag. Above 200, the match is unplayable. Game traffic uses UDP, fast, fire and forget, packets occasionally lost. Critical events ride a parallel TCP channel as backup. Both run at the same time, so a dropped packet doesn't desync your view. Distance matters. Edge points of presence, regional data centers, shave 200 milliseconds off cross-continent paths. Your packets ride the backbone, not the public internet. The CDN doesn't just serve static assets, it also brokers your live game traffic to the nearest edge pop. From there, dedicated fiber routes you to the actual game server. Mobile constraints. PC games assume gigabit internet and a wall outlet. Mobile games can't. Battery, heat, data caps, spotty Wi-Fi. Mobile fights physics, not just software. A game that drains your battery in 20 minutes is a game you stop playing. Every frame, the phone has about 16 milliseconds to receive state, render the world, accept your input, send it back. Network packets must be tiny, or you blow the budget. Maps, skins, weapons, gigabytes of assets prefetch over Wi-Fi when the app is idle. Once you press play, almost nothing else loads. You run on what's already cached. Position data in particular gets quantized. Instead of a 32-bit floating point coordinate, the server sends a 16-bit integer. The phone reconstructs the approximate position, accurate enough for what your eye can resolve. Anti-cheat, wall hacks, aimbots, speed hacks. The system has to catch them without false flagging legitimate players. Two anti-cheat layers run simultaneously. A client-side module on the phone watches for memory tampering and unauthorized binaries. A server-side module watches for impossible motion. Together, they cover most attack surfaces. Every shot, every move, every kill streams telemetry back to the anti-cheat pipeline. Heuristics flag obvious anomalies. Instant teleports, hits through walls, perfect tracking through smoke. Hard cases go to an ML model. 100% headshot rate over 1,000 kills. Aim snap with frame-perfect accuracy. Patterns no human can produce. The model queues those for human review or autoban. All of this runs in real time, frame by frame, while the match is happening. By the time a cheater finishes their game, anti-cheat has often already decided their fate. Voice and replays. The features you forget exist until they don't work. Voice chat doesn't ride the game protocol. It uses a pub sub topic per squad. Your phone publishes audio, your squad mates subscribe. The game server doesn't even see the voice traffic. While the match runs, the game server is also writing every state update to a replay stream. That stream lives in object storage forever, compressed, indexed by match ID. When you watch a replay later, the viewer doesn't pull a video file. It pulls the original state stream and re-simulates the match. Different camera angle? Just re-render from a different perspective. Voice has a tighter latency target than the game itself, 40 milliseconds. Lower than game server latency, because voice cutting out feels worse than a one-frame teleport. When the match ends, the system has to remember it. Your rank change, your XP, all before you tap start on the next match. Match results don't write to a database directly. They enter a queue. A worker drains the queue, fans the result out to ranking, replay, analytics, profile. Each of those is a separate write to a separate store. Different stores for different needs. Rankings live in a relational database. Joins are cheap, queries are predictable. Replays sit in object storage. Huge, write once, read occasionally. Analytics flows into a warehouse for batch analysis. Your personal stats, kills, KD, time played, level, right back to your profile in a key value store optimized for low latency reads. That's what loads when you open the app next time. The analytics warehouse retains every shot you've ever taken, every move, every death, every loot pickup. Engineers and designers query that data to balance weapons, tune maps, spot meta shifts. Global scale. BGMI runs across continents. Player traffic stays local. Player data syncs globally. Each continent runs its own pop cluster. Asia talks to Asia pops, Europe to Europe, Americas to Americas. Cross-continent game traffic is fundamentally unworkable. Too much latency. Inside each region, hundreds of game server clusters auto-scale with demand. Peak hour spikes get matched with new instances within seconds. Off-peak hours, capacity drops to save cost. Your packets stay local. Your profile, friend list, rank, those sync globally. So when you log in from another country, you find your data waiting, but the matches happen on local infrastructure. The global database is replicated across continents. Writes can happen anywhere. Reads happen everywhere. Eventually consistent. Your rank from a match in Asia takes a few seconds to show up if your friend opens the app in Europe. Let's put it together. Hundreds of engineers, millions of lines of code, all so you can play one match. Every tap follows the same path. Gateway, matchmaker, game server. Same protocol, same handoffs, every time. The system you've just learned is the system serving every player, every match, every day. 6 systems working together. Login, matchmaker, game server, voice, anti-cheat, storage. The architecture of every modern multiplayer mobile game looks roughly like this. Now, you can see the machine behind the curtain.